Hello everyone and welcome to another Leetcode. So today we'll be doing a Leetcode medium question, which is to count the number of islands. So given an n by n grid, which represent 1 with ones and zeros, which represent land and water respectively, we have to return the number of islands. So an island is surrounded by water and is only formed by connecting adjacent lands horizontally or vertically. So we may assume that all four edges of the grid are all surrounded by water. So taking example 1 as an example, we can see that in this example right here, we can see that there is one island that is like this, simply because they are all connected via horizontally or vertically. So that's why the return output is 1. And for example 2, we see that the output value is 3. This is because we see that there are indeed 3 islands, the first one being this, the second one being this standalone one, and finally this last 2 right here. Take note that we do not consider them in terms of diagonally, because that's not what the question states. So that is why we see that there are 3 islands right here. So what I think is a possible solution is that firstly we need to recognize when we meet an island. When we meet an island, aka we meet a value of 1, then we need to somehow recognize the whole thing as an island. So that will mean that for the one that we meet, we have to explore it along its sides. So both up, down, left and right. And for its sides, we also have to explore if there are any more ones which represent land. So that will be how we can recognize this island. So using example 1 as an example, the moment we meet a 1 right here, we have to also explore the left and right. And for its neighbors, we have to explore the left and right, up and down respectively. So that will mean that we will need a searching method to help us search through everything right here. And one idea we can use is definitely BFS or DFS, aka breadth first search or depth first search. So we have to recursively search through all of its neighbors so that we can recognize all of them as the island. So in order to recognize them as an island, whenever we meet a value of 1, for this question, we can simply set it to become true. To take it as we have already recognized this island as an island. So when I meet this 1 right here, I'll set it to true, and same for all the other values right here. They will all simply be turned to true. So that will mean that as I iterate through the grid, and I meet an island, then I'll recognize the whole island. This will mean by setting them to become true, in this case. So that will mean that when I meet a value of 1, what I will do is simply to have a global counter variable. So let's just say a count equals 0, and then I'll add 1 to the count. And as I add 1 to the count, then I'll use my BFS or DFS method to recognize the whole island. This is because as I change all the values to become true, that will mean that for the subsequent iterations, these islands will no longer be treated as 1. So that is why for this count plus equal 1 right here, it will actually count the island and recognize it as a whole entity, simply because I have changed the values to become true. So that will be how the general algorithm will work. And now let's move on to the coding explanation so that I can give you a better idea of the answer.
Okay, so now let's move on to the code. So as I mentioned just now, what we need is a global variable to keep track of the count. So at first we can just initialize it to become 0. And then what we have to do is to look through the array, and when I meet a value that is a len, then I have to recursively make all the neighboring values become true, so that I can recognize this whole island as len. Okay, so I'll iterate through the grid. Iterate through the grid. If I meet len, which will be a string value of 1, recursively convert the island to be recognized as a whole entity. done by making all the 1 values to become true. So that'll be how the general algorithm will run. So let's iterate through the grid now. Range of the grid, and for this should be the length of the grid. Oh, sorry. And for j in range length of grid 0, we can just take grid 0 because it will just be the length right here of each array inside the grid array right here. So what we'll do is just check if the value is 1. You must remember there is a string value right here as stated. So if it's 1, right, what we'll do is to run our, in this case I'll just code out a BFS solution, but I can feel free to do out a DFS one as well. Okay. I'll just run my algorithm BFS on I and j. And what this algorithm does will also help us to recursively search through the vertical horizontal areas and turn everything, all of them to become true. Before that, what I'll do is increment the count as well. So I'll just add a count plus 1. After that, once we have finished running the algorithm, all we have to do is to simply return the count right here. So now let's code out our VFS algorithm now. We shall have the I and j values respectively. So I will just be like the index along the length, along the width, while j is the index along the length. So now we just have to validate our I and j first. So what I want to do is to make sure that it's within, my I and j are within the appropriate index range. So it needs to be at least 0 and less than the length of the grid for I. And for j, it also needs to be at least 0 as well. And it needs to be less than the length of the, we just take it as grid 0, which is the length of one of the arrays right here. And what we want to do is to also check that and make sure that it indeed has a value of 1 if you want to turn it to become true. So and grid ij is equals to 1. When this is the case, what we will do is to make the grid and set it to a value of true. And after that, we'll use this function to recursively search through the left, right, up, and down respectively. So what we have to do is to run through BFS again. First on the left, then on the right, then above, and finally down. It's okay for us to have all these value with -1 plus 1 right here because I'll have a validation check. So we will not get an index out of range. So with this, I believe the solution should work. For the space complexity, I believe if we ignore the recursion stack right here, it will be an O of 1 because what we are doing is to actually make changes to the actual array itself. But if it's given the case whereby you cannot manipulate the actual values inside the grid, we can just simply create another n by n grid that will just store whether the values are visited or not to help us do the check. And as for time complexity, I believe it will be your O of mn because we have to check through all the possible values in the grid. And as such, that's why the value is mn, as given by the question right here. So yeah, I believe this solution should work. So as you can see, the solution does work. And as always, if you have any questions, then feel free to leave them in the comments down below, and I'll do my best to help. So thanks for watching, and yeah, see you.